Hey guys, let's get started. So today we'll be discussing this Google question, right? In this given problem, this was asked in the Google L3 or L5 L4 interview. I'm not sure, but the given problem starts with saying that we have a start and the end logs of an RPC server, that is some remote server, and these events have a particular timestamp associated to it, right? Then we need the question is asking is that you need to return true as soon as the server times out, right? And if no server times out after processing all the logs, you need to return false, right? So yeah, I'm actually uploaded the solution over here. So let's see that if you can actually see make sense of the solution or not, right? So what they say over here is that key the person implemented the solution using a hash map, right? So what it eventually did was that it maintained a hash map in the format of event ID and the time. Let's say that you got an event ID 1, and this is the start, right? So you store the time at time is equal to 0, right? And let's say that you got another event which is corresponding to ID 1, but this time you receive the end of this particular event, and you say that let's assume the global timeout value is 2, right? So right now if you get these event, so far so good, right? You use an hash map, you store the starting of the event, and you see that okay, I got the start of this event at the time was equal to 0, and I got the end of the event and the time at that given particular point was 1. So this given event has not timed out, and I can just say that okay, this works, right? So it's exactly this person exactly did this, right? To use the hash map to track all the events, like just assume that it's int format, and the problem was that the person got rejected, right? The person actually got rejected from this interview. So yeah, that's what the later point was that the intended solution was that to track all the active RPCs. Okay, so let's go ahead and try to explain you what was missing from this given picture, right? So let's say that you got particular events. Let's say that event 1, 2, 3. Actually, I should have put it like this, right? 4. Okay. Now assume these are all start events and these are already present as part of your log, right? These are all start events and these are already present as part of your log. Let's put some time to it also. Like this particular event, this arrived at time 0 and the next event arrived at time 3, and let's say that this arrived at time 4 and this arrived at time 6, right? So far so good, right? Now let's say that you got event 3 and you got the end of the particular event 3 at the given time, let's say that 7, right? Even 3 times is 7. And let's assume the global timeout is, let's say what, uh, 5 maybe? Yeah, 5 will do, right? So eventually you get to come here and you see that, okay, the event 3 end time is 7 and I already have an event 3 in my hash map maybe. And I subtract these two events, like 7 minus 4, that gives you 3, and the global timeout is 5. So you say that, oh, we are not timing out. But but you forgot a very crucial thing over here. Think about the start events. Think about the start events, right? The very first event has timed out, right? Even though since you were relying on the fact that you were tracking the start events and you were using the end event to check if the end time minus start time is greater than timeout, you failed, right? Because eventually what has happened over here is that you track the event ID and you say that okay, this time is 4, 7 minus 4 is 3 actually, right? And this is within the global timeout range. But the very first event had started at 0, and this event is still active, right? This event is still active. But when you use this end time minus but the current time is 7, right? The end time has arrived at 7. That means 7 seconds has already passed, right? So this event has already timed out, but you're still returning true, which is incorrect, right? Because the question is asking you that you need to return true as soon as the server times out, right? So let's see how we can actually approach this problem. So to approach this problem, we need to maintain everything events in the orderly format. And whenever we talk about the order, take a pause over here, take a pause, think for yourself what we can use to what data structure can we use, right? I'm trying to resume now. So we can eventually use a linked list. but not a very simple linked list. We are going to use a doubly linked list. I'm going to tell you why. So let's assume that we have this format of the linked list, right? And start time and next previous, right? So we have been provided all of this. And let's say that we are using the start pointer. As I had mentioned that we are using a doubly linked list, right? So we are using a start pointer, we are using a null tail, which is the end pointer. Let's call it end, right? Which makes more sense. Now, how will our list look like? So we will do a quick initialization. Let's say that someone calls our timeout function, and when this happens, right? Okay, we have already initialized. So yeah, we can have a global timeout for this right now. And G timeout is equal to, let's say that this is equal to 0 right now. We can initialize this given timeout with the value of timeout itself over here, right? And then let's say that we do a process event. And what eventually comes as part of this is that, so everything over here, I'm just plainly assuming, right? Because in the interview, the person has not specified any such things, right? So when we are trying to process the events, the very first thing we can do is that we can check the head, right? Or we can check the start. So if the start do exist, right? And the current time minus the head start time, right? If this given is greater than equal to G timeout, then we can safely say that the event has timed out, right? And we can just return true. Some RPC has timed out, right? And the thing is that if the event has not timed out, what we can do is that we can process this event, right? We can try to process this event, right? So now what happened is that since there can be a follow-up question to you as well. Over here, there can be a follow-up question that let's say that you receive the end of the event, you can remove the end and you can remove the start as well, right? So this particular question can also be asked to you. Now, in that given scenario, you can't just simply use a linked list to scan over all the events, right? And just find the start of this given event, right? So you got my point, right? Let's say that the question was just simply that you need to return if some event has timed out, and that's it. You can simply check this thing, right? And further you can do some processing to add this given node. This you can create a node and you can add it to the particular linked list, right? This is one thing which you can eventually do, right? But let's say that someone tells you that now you need to also remove, once you get the end of the event, you need to also remove the start of the event, right? Such that it's not present in our list. And we can safely assume the list of ours, which is start, it always containing the active, you can say it is always containing the active events, with the events which are currently active, start time is present, right? So that's one thing which you need to do over here. So so for that given thing, what we can do is that we can use a hash map over here, right? So we can use a hash map because eventually we cannot just go and traverse our linked list tool. It's very expensive thing. So let's use an hash map, something like this. And let's say that we got a start time over here, right? Now let's go ahead and create a new node, uh, something like this. And let's provide some event ID to it, right? I don't want to do the labor work tool, but anyways, someone has to do. Start time is equal to the current time and next. Okay, so if this particular event is the start of the event, what we can eventually see is that the next will be null pointer because we are appending it to the end of the linked list. And the next thing is that we can add the tail, right? So after this, this current event previous will be equal to the tail itself, right? And what will eventually happen is that if there is no head, like let's say that the head was empty, so what we can, or the start was empty, right? Or let me change it quickly to, I'm sorry, I keep confusing the terms over here. So if the start is empty, what we can see that the start will be equal to the n itself over here, right? Else, what can happen is that the end next will be equal to n itself, right? So currently, what will happen is that if the head pointer, okay, if the head pointer is not present, sorry, if the head pointer is null, this node becomes the start of a given linked list, right? Otherwise, what might eventually happen is that the previous end next will point to the current one, right? And that's it, right? We are just trying to append this given link thing. And what we can say that we can update our end to point to current one, and we can also add this event to our hash map. So for the event ID, we can just add it to the hash map itself, right? So now hash map will contain the node for this thing, right? Now, what might eventually happen is that, let's say that we got an end event. We have received the end event. So what you can eventually do is that we can find the particular event ID. Once we have found the particular event ID, we are going to check if this event ID exists, right? And what we can say over here is that this node, let's assume that we are able to fetch, we are able to get the pointer, and let's say that we found the node. And what we can do is that we can remove this particular node, so that node.previous, if it exists, we can quickly say that the node previous dot next we equal to the next. So this is simply a linked list deletion, right? It- And if the node next do exist, so node next dot previous will be equal to the node dot previous itself over here, right? So these are some basic things which we can do as part of the processing, right? But what if the event previous event does not exist? What if the previous event does not exist? That means this event will become the head. So start will be equal to the node itself, or this particular node dot next, sorry. So what I mean to say is that, let's say that we are trying to process this given event, right? We found out that the previous node does not exist, right? The previous node which we found the event somewhere in our linked list, right? And we found that the previous node for this given linked list does not exist. What we did was that we say that the start will now be the pointing to the next of this part, right? And same thing applies for the tail itself over here. What we can say is that for the tail end, we can say it will point to the previous one, right? If it if the node dot next does not exist, that means node dot next does not exist. That means the end has to be updated now. Okay, you can spend some time to understand more about it, dude, but it's pretty fun. And then finally we can erase this given event and we can delete the node. So two things will happen over here. The start event which existed in a hash map has to be erased, and we need to delete the particular node from a given linked list because we have done the relinking, right? So with everything, we are good to go, and we can return at the end. If there is nothing, we can just return false, right? So this was a given problem which was provided in the Google, and it's actually a quite fun one, right? So that's pretty much it. I think so. That's pretty much it. You guys need to know, right? And I hope so. It was fun, right? So yeah, please do ask me if you have any such questions in the comment section. And thank you guys.